Hey everyone, in the previous short video, we discussed why 3 into 0.1 is not equal to 0.3. The root cause is that 0.1 is stored as an approximation in binary. Let's explore why and how numbers like 0.125 are stored perfectly. Decimal values like 0.1 are written in base 10, but computers work in binary, which is base 2. This introduces approximation errors for some values, and 0.1 is one of them because 0.1 is a repeating fraction in base 2, similar to how 1 by 3 is a repeating fraction in base 10. And to convert the fractional decimal value to binary, we repeatedly multiply the fractional part by 2, recording the integer part at each step until the fraction becomes 0. Let's see how. So we multiply 0.1 by 2, which is equal to 0.2, and the integer part is 0. Now we again multiply 0.2 by 2, which gives 0.4 with integer part as 0. Now we again multiply 0.4 by 2, which will give us 0.8 with integer part as 0. Now we multiply 0.8 by 2, which gives us 1.6 with integer part as 1 and fractional part is 0.6. So we again multiply 0.6 by 2, which gives us 1.2 with the integer value as 1 and the fractional value as 0.2, and the cycle repeats. So the binary number we will get is 0011 repeating infinitely, and this infinite repetition cannot be stored exactly in finite number of bits, and hence 0.1 in decimal is stored approximately as 0.1 followed by some zeros and then some non-zero digits like 555, 111, 5123 and so on. But not all decimal numbers face this problem. Numbers like 0.125 works perfectly in binary because they are fractions of power of 2. For example, 0.125 is 2 to the power of minus 3. Here is how it will convert. We start with 0.125 and multiply it by 2, which will give us 0.25. We record integer part as 0 and we again multiply 0.25 by 2, which gives 0.5 and integer value is 0. And now we multiply 0.5 by 2, which gives us the value 1. So now the integer part is 1 and fraction becomes 0, which completes the conversion. And we get the exact binary representation as 0.001. So now you know why 0.1 isn't stored perfectly in binary and why numbers like 0.125 are stored accurately. If you enjoyed this explanation, hit like and follow for more programming insights and tips.